I just ate Wingstop and it tasted so good. But in this video, we're going to talk about the differences between direct and limit comparison tests. Now, just a quick heads up, most of the time, if you don't know whether or not to use direct or limit, a lot of the problems you're going to get, actually nearly all the problems you're going to get in Calculus 2, where you can use direct, you can also use limit. But sometimes when you can use limit, you can't use direct. So honestly, if you don't know which one to pick, just pick limit comparison test, right? I think limit comparison test will work for nearly all the problems that you will use for direct. But let's go ahead and start off the video. First things first, we have a series with the sequence a of n. And usually, you're going to try to find your compared function, or compared sequence. Now, the reason why you want to find this is because we're doing a comparison test. So the whole point of the comparison test are to compare two different things. A of n and b of n are the two compared functions, right? And b of n is a new one you have to write. Usually for b of n, you only worry about the largest exponents. So if you had n squared plus 3n minus 1 over 3n to the fourth plus 5n squared plus 7, doesn't matter. You'd only care about the largest exponents on the numerator and denominator. So b of n would go to n squared over 3n to the fourth. And you could just remove any coefficients if you'd like to find b of n to get n squared over n to the power of 4 to get 1 over n squared. And this would be your b of n if this right here was your a of n. So if this was a of n, your b of n would simply be this function 1 over n squared. Right? Only care about the largest exponents in the numerator and denominator. Now, the thing that really changes the most between these two tests, direct and limit, are the conditions. First off, we want to name the similar conditions, of course. Both the conditions state that your series a of n and b of n must be positive. Must be positive. So, no alternating. Okay? No going between negatives. All the numbers must be positive. But what really differs them are the convergence and divergence conditions. So let's go ahead and state the direct comparison conditions here. The direct comparison conditions state that b of n, let's say if b of n converges, then a of n also converges. And if a of n diverges, then b of n also diverges. Now the thing about these conditions is that you must take them literally, okay? B of n, so if your compared function, if your compared series b of n converges, then a of n converges. Well, what if b of n diverges? Well, if b of n diverges, then this says nothing. You need to use a different test. If you use the direct comparison test and b of n, this guy, diverges, you do some p-series test or something like that, and this guy diverges, your test is inconclusive, all right? The only results you can get from this test are if b of n converges, then a of n also converges. So this guy must converge or else your test is inconclusive. Now, what you really need to find out is, like, if a of n diverges, then b of n diverges. I mean, like, you would just use divergence test on this guy in order to determine that. Really. You would literally just use divergence test. So, I guess the direct comparison test wouldn't really help in this case. But, of course, if a of n diverges, then b of n should diverge, since b of n is some compared series. Alright, what about the limit comparison? Now, the way you find b of n is still the same, but the thing about this is that in order to use the limit comparison test, you first need to take a limit, right? So as n approaches infinity for a of n over b of n. So you need to put the functions over each other and take the limit up into infinity. And the answer for this limit could either equal be c or l, right? I think most textbooks use L. Most textbooks should use L, so L is your answer for this limit. Now, literally every single time you do this test in your Calculus 2 class, at least, you're gonna get some whole number at the end. You're not gonna get leftover variables. You're gonna get either 0, 3, 5, I don't know, infinity even. Okay, but all these work out. You just need to follow the specific conditions based off the answers. So once you take this test and you find L, if L is between 0 and infinity, then A of n and B of n converge and diverge together. Now, this is the reason why I say that limit comparison test is more versatile, because they converge and diverge together now. So in the previous comparison test, direct comparison test, if B of n diverges, your test is inconclusive. But now, in the limit comparison test, if your B of n diverges, then A of n can also diverge. All right? So this guy is more versatile. They converge in the two series, A of n and B of n, diverge and converge together. You don't have to worry about B of n diverging and getting inconclusive. All right. Well, what if L is equal to 0? Well, if L is equal to 0, then the condition is B of n converges, then A of n also converges. And only that. All right. So if the answer for your limit, L, after taking the limit from n to infinity, is equal to 0, then B of n converges. Then if B of n converges, the A of n also converges. Now, what if B of n diverges? Well, there you go. Your test is going to be inconclusive. But most of the time, you're going to be using this condition right here. Most of the time, L is going to be some integer from 1 to infinity. All right. It's going to be 1, 2, 3, 4, maybe even a fraction, 3 over 8. Right. So take back what I said about integer, actually. Yeah. Most of the time, it's going to be some real number. All right. It's not going to be 0. It's not going to be infinity. It's going to be from some number between 0 and infinity. So L, most of the time, you're going to use this condition. That's why limit comparison test is better. But in the case, off chance that you get L is equal to 0, then only if B of n converges, then you get a result. Okay. All right, what if L approaches infinity? Well, if L approaches infinity, then only if B of n diverges, A of n also diverges. So in the case where L is equal to infinity, if B of n converges, again, test inconclusive. All right, so you have to follow these conditions to, a T. But anyways, that's really all. Literally just memorize these conditions. Like a good way to memorize this, what I used when I took the class like literally a semester ago, 2 semesters ago, I think. Yeah. Was for direct comparison, you can only determine convergence. For don't worry about this bottom condition. You're really never going to use this. You would just use divergence test. You wouldn't even have to use the direct comparison test for this. What else? You're going to use p-series a lot for both of these, right? You're going to use a lot of p-series. And also, let's see, limit comparison test, more versatile, right? If you get some number from 0 to infinity for L, you can determine both convergence and divergence based off of B of n. So, really, that's all. I'm going to drink my Diet Coke because Diet Coke tastes very good. But, as always, if you have any questions, put down in the comment section. And if you found this video helpful, consider subscribing and liking the video. Thanks for watching.